In at least two of these paradoxes that we've covered, we've been able to solve them just by applying the fact that the universe isn't static and it isn't infinite. In today's paradox, we're going to be looking at one of the paradoxes that first challenged the infinite universe and set the finite universe paradigm in motion. Hello, welcome back to the channel and welcome to the final part in our astronomical series where we'll be covering the Kelvin paradox. Well, actually the recognised name for it is the heat death paradox, but if I titled the video that, I think you would have guessed things already. In part 4 in the black hole information paradox, we talked about the concept of entropy and how it is basically a measurement of work done that can be done on a system. We said that if we took some ice with some hot water as our system, the relative entropy is quite low. The system isn't really in much thermal equilibrium. But fast forward, and as the hot water starts to heat up and melt the ice, we later on end up with just one single, bit of water that is just semi-cold. So the water has now reached thermal equilibrium and all of the particles kind of have very similar, if not the same, properties. No more work done can really be done within the particles, on the particles, or by the particles. So now entropy has reached its maximum within this system. Systems always move towards thermal equilibrium and work will be done to reach that equilibrium. Therefore, entropy can only really increase or stay the same. It can never really decrease. You can never really just get the water returning back to ice, if you will. So what happens after billions upon billions of years when the Earth finally dies and gets swallowed up by the sun, which then explodes and it dies and gets reused by another star, which then explodes and goes supernova, and then all of that matter gets fed into a black hole, which then evaporates, and so on and so on and so on. What happens when there is no more work done to be done on anything within the universe and everything has reached total thermal equilibrium? This is the so-called heat death of the universe. It is when everything everywhere has achieved thermal equilibrium, and currently we are nowhere near it, and it is nowhere within the near future, even if it is what's in store for us. Funnily enough, this universe would actually be very dark and very cold, like the complete opposite to Olber's paradox, which is quite remarkable. The reason I call it Kelvin's paradox is because Kelvin was the one that postulated it first. So now, having extrapolated the laws of thermodynamics all the way into the far future of the universe, Kelvin has basically set the scene for his heat death paradox, which is basically a proof by contradiction. See, if the universe was infinite and static, then it must have also been infinitely old, having no start age. However, we know that although it may take a lot of time, things do move to reach thermal equilibrium. So even if it took trillions upon trillions of years for the universe to reach thermal equilibrium, it should have reached it already, given that it is infinitely old. And yet it hasn't. And yet in the solar system, we have ices on Pluto that haven't evaporated or sublimated into gases. The sun, for example, its core is millions of degrees Kelvin, and yet the surface is only a few thousand degrees Kelvin, so there's clearly no thermal equilibrium that has been reached here yet. Kelvin uses this to argue that the universe cannot be infinitely old or sempiternal, but it would be very much later until the empirical proof, so the redshift of galaxies and Hubble's law, would show us that an expanding universe, which would later show us that, well, if we roll back time, eventually everything would have started at a point and therefore there would be a start date. And that concludes all of our astronomical paradoxes. Thank you so much for joining me as I discuss all of these interesting concepts and paradigms. It was really fascinating to learn about them and write about them. Now that the series has ended, I'm actually going to be talking about my own research in the upcoming videos. So stick around for that and I will see you very soon.